So today's discussion will be in continuation with the ongoing circles discussion. Okay, so today we'll be taking on some of the topics like perimeter, area of the circle. Okay, then areas of the sector also, minor sector, major sector. What are the segments if we say minor segments, major segments? Okay, and some of the techniques maybe. Let us see. Perimeter. Okay. So as we all know, the outer boundary of the circle. Okay. So if we suppose, let us take an example small. Okay, suppose this is a circle. Okay. And suppose if you're taking this point and a person is standing over here, if he walks along this path like this, okay, and covers one full distance, finally again reaches at this point. Okay, so what would be the length of this that he has covered? Do you know what it is called? When he covers one full, when he walks along the boundary of the circle, okay, maybe starting from a one point and again reaching at the same point, walking along the circle, so that is called as perimeter. Okay, it is
Yes.
also called a circumference. Both ways you can say that. Okay, so now since we know that there is a center to the circle, let us say the center as O. Okay, and if suppose I'm taking a line, okay, something of this sort, ये O मान लें, the dot that I've shown. Okay, so if this is the center, the dot that the point just below the dot. Okay, and this is radius R, both the sides. So this is the line that I've drawn. Take it as a diameter. Okay, since it is passing through O, so whichever line passes through O, take it as a diameter. What is a diameter? What is the length of the diameter? You know.
For the longest line possible in a circle.
Hmm. Okay, ये इसका diameter है. Let us take points A and here take let's B. Okay, AB is the diameter. So there is something unique about this thing because circles are everywhere. Okay, so we see the outer boundary that is called perimeter, and this AB is called as the diameter. Okay, so now there is a let us talk about that. People have found out that the first of all, I'd like to say what is parameter. Okay. Maybe okay, whatever is the perimeter definition wise, we know that okay, it is the boundary. Now perimeter divided by diameter. Okay, so this is a constant ratio. Do you know what it is? Always, every time. Perimeter divided by diameter. Suppose I've given you a string and I am saying that okay, make a circle out of it. Just exact, I mean, it should be the perimeter of the circle. So you can like measure that string. Okay. And once you are completed with making a circle, and you can measure the diameter as well. Now, if you divide perimeter by a diameter, okay, that means the ratio of this perimeter to the diameter is always a constant thing, always a constant ratio. Okay, constant thing. What is that? People have found out that earlier. Do you know that? So always remember this perimeter, or you can say circumference also. Okay, that is denoted by Greek letter pi. Okay, getting it? So we are not just directly jumping to the formula, we are just right from the start. Okay, if you have got the perimeter, length of it, and if you have know the diameter also, so always in a circle, perimeter to diameter, okay, the ratio of perimeter to diameter is always a constant. So now suppose if I take, okay, ये है suppose, okay, suppose this is first one, is, let us take Suryadev. Okay, और sun, ठीक है, ये है as you are perceiving it from here. And second one, suppose it is a chapati. Getting it? So in both these cases, if you know the perimeter and if you know the diameter, then the perimeter divided by diameter, or the ratio of the perimeter to diameter, will always be a constant. Okay, so all these things are linked through a constant. Getting it? Getting the gist of it? Maybe you are taking a bigger circle. Okay, so if that circle you're drawing maybe through a thread, if you know the length of the thread and if you know the diameter also, if you are taking their ratio, then it is a constant. Okay, and if you are taking any photograph of the sun and if you are measuring like okay, if it is circular exactly, and if you're getting the perimeter and you're like measuring the diameter also, okay, these activities you are doing, and then you're taking the data, and then you are seeing okay, it is again coming out to be pi. So all these circular bodies, they are connected through one common string which is called as pi. Okay, getting it? So this is the gist of it. Don't just remember pi as a number, okay, 22 by 7 or 3.14 or something, okay? Just take it in a very conceptual manner that it is originating from circle, okay? Whenever you know the boundary of the circle and you know the diameter of the circle, that is the length of the longest thing, okay? Longest chord. So if you know the distance, if you know the exact measurement of both of them, and if you divide them, it will come out to be pi. What is pi? You know that?
Sir, 22 by 7.
So generally we take it 22 by 7, or in decimals we take 3.14. What do you think, is pi a rational number or irrational number?
Yes, sir.
क्या है ये?
They're actually not irrational, it's irrational.
It's irrational, okay? Irrational number. Okay. What is the basic difference between irrational number and rational number? Do you know?
Sir, irrational cannot be presented in the form of P by Q.
Okay. So ये तो आप कर पा रहे हो 22/7.
सर ये राउंड ऑफ कर लिया ना इजी बनाने के लिए.
Hmm. देखो, the definition wise, if suppose you are writing, you can write any number in the form of p by q, and the resultant that is coming, either it is a exact, okay, exact decimal number. For example, 3 by 4 if you're taking, okay, so what is that? 0.75 something, okay? Or suppose you're taking 11 by 3, कितना आ जाएगा ये? 1.666 like this, okay? ठीक है? So if you see this number, this is in p by q form, and the value that is coming out is either it is repeating regularly, there is a repeating pattern to it. So here there is a repeating pattern, 0.66666. Now you'll get it till end, okay? चलती रहेगी वो. Either that is the case, or you are having a finite like decimal numbers. It is stopping at some place, okay? So that is called as a rational number. ये चीजें सब rational हो. ठीक है? So two clauses, rational number, either there is a repeating pattern like 1.666, or maybe in a different fashion something else could be there, but there is some kind of a repeating pattern. Maybe 5 4 is there, 5 4 5 4, again 5 4 5 4 is coming, okay, and it's not stopping till the end. Matlab you can do it like infinitely, okay? So that is called a rational number. Or if you're getting like suppose 3 by 4 point 0.75 maybe, so it is like finishing at that point. All other numbers, okay, you're dividing one number by other, but the resultant is coming out, it is not like repeating also, it is not getting fixed also, okay? So in that case, for example, if you're saying that 22 by 7, okay, you can take any other number also. So the numbers, they do not have the repeating pattern also, and they are not finishing also, they are not like stopping anywhere, okay? So till they're going. So these are called irrational numbers. So pi is one such number. And इंडियन मैथमेटिशियन आर्यभट्ट, ओके, उन्होंने भी बताया इसके बारे में, ओके. 4476 550, okay. he also gave the approximate value of pi. उन्होंने क्या बोला? उन्होंने बोला कि भाई ये 62832, ओके, इस तरह से कुछ बोल रहे हैं, ओके, इसका आप निकाल सकते हो, ओके, नियरली इक्वल टू 3.1416 लाइक दैट, ओके। श्रीनिवास रामानुजन ने भी बोला ये चीज, ठीक है, इंडियन मैथमेटिशियंस है ना। he has also like calculated the value of pi correct to many million places of decimal, ठीक है, many places of decimal, I will write many places of decimal, okay, okay, तो ये इंपॉर्टेंट है। सो 22/7 यू कैन राइट इन फॉर्म ऑफ p by q, ऑलवेज रिमेंबर, ठीक है, number can be written in the form of p by q where q is not equal to 0 since it is 22/7, but you divide it, do it on your copy, and you will see that it is not ending, the number is not ending, okay. So then you'll make out, okay, this is an irrational number. Getting it, the definition that you have told? Always remember this. That is like 22/7 is also in the form of p by q, but it is not. Either it is not having a repeating pattern or it is not ending at some place. Okay, it is just going infinitely. So in that case, it will be a irrational number. So we just need to focus on that. Okay, and in exact terms, we say it is non-terminating and non-recurring. Non-recurring means non-repeating. Okay. तो टर्मिनेट भी नहीं हो रहा है और रिपीट भी नहीं कर रहा है, तो फिर इट इज एन इरेशनल नंबर। एंड इफ इट इज रिपीटिंग और टर्मिनेट हो जाता है, ठीक है, आइदर तो रिपीट होता रहता है तो भी ठीक है, और आइदर इट इज टर्मिनेटिंग और आइदर इट इज रिपीटिंग, ओके, सो देन इट इज अ रैशनल नंबर, ऑलवेज रिमेंबर दिस, ओके। सो नाउ okay, getting this point? So perimeter or circumference divided by the diameter of it is called as, taken as the irrational number, and all the things, all the circular, if I am giving you like n circles of different sizes, different radius, okay, so they are all linked by this constant number, okay. If you know the perimeter of them, if you know the diameter of them, and you take, so they are all linked with this pi, okay. So this is the very basic definition, and suppose if you want to go into the research of mathematics anytime in your life, then this will help. Otherwise you will have n number of formulas, you can like mug up them, okay, you can just do n number of calculations, but this is the very basic and crux of it, and it is also like related to cosmology, okay. I've seen many things, okay, after many years these things are coming, so these are very simple things, so this is a very basic concept, okay, you should know that. Now let us take, okay, so parameter by that formula it can be written as pi, okay, into diameter. Can I write that? pi, we write pi with color. Okay, into, and it is diameter d a m e t, diameter. Okay, what is diameter? Suppose the radius is r,
The 2R.
2r हो जाएगा. Okay, if radius is equal to r, then diameter equal to 2r. Okay, so what will be the above formula for perimeter? It will come out to be pi into 2r. Okay, you can also say 2 pi r. Getting it? Okay, very simple, but it like go a long way. You should know this. Okay, so how we are coming at arriving at this formula? Perimeter divided by diameter. It is a constant, that is a irrational number pi. Okay, it's a Greek letter denoted by Greek letter. Okay, so there have been some claims that it is not that number. Okay, some new research is coming up. Okay, but what I would say is, because since circle is a finite resource and you can draw a circle with a compass, you always try to do that and then just measure it. And maybe you have got a thread. Okay, just try to make a circle. Us thread ki just take the length of it. And always like with the help of a scale, you can measure the diameter of the longest cord and passing through the center, so that you can measure from the scale. You have got a thread, just say कि आपने उसकी boundary पे लगाया. Okay, so you know the length of the thread, and just have those values and do it for a couple of times and just divide them. This is a small project you can take. Okay, you can build a table around it and you can see what are the values, exact values coming. Okay, maybe some sort of precision is required, but you can at least do that. So you have got a light long thread, and if you can just, okay, just take it as a parameter and just draw any of the circles and take that thread, and maybe you can cut it into pieces also just to fit it exactly, and just have the length of it. Okay, length you can the length after having the parameter, and you can just measure that length on the simple scale also. Okay, have the scale, just measure it, scale में देख लो कितना आता है. Okay, and just measure the longest chord, वो भी आप you can take help of a scale, and just have the value of the pi kitni aa rahi hai. Okay, you should do these experiments, because once these books are out, once we are studying, okay, once we have so many resources, we just never like bother to take this experiment. This is a very basic experiment. If everything is gone, you should like, this will help you. Okay, it is as good as like a solar flare is coming and all the network has gone, then what knowledge have you got? Like, can you do real things? Do you know the principle? Do you know the concepts? Okay, if this concept is there with you, okay, you have got a thread, एक बना दिया सर्कल उसमें से, है ना, you've got a compass बनाया and like measuring it, है ना, biggest chord you already know, वो भी measure कर ली, and just you're collecting the data, nice table you're making, and just seeing the value of, okay, whether it is coming same or it is coming a little bit different. Okay, so this is my ground level analysis, research analysis. Okay, this is how any new thing is done. Once we are having the observations, okay, this is, people are saying this, I'm just taking it for granted, let me just try it. Okay, in your summers, or maybe you can have this pi project, small pi project, just try to do it with different scenarios. Okay, it's a very basic one, but it will go a long way, and it is very useful also, I know that. Okay, so this is called as perimeter, or you can call as it circumference also. Perimeter. Okay, just for your sake I'm writing. Okay, or circumference. ठीक है. Okay, you can call it anyways. Now we'll move to the area. कितना होता है ये? Can we take the direct formula out of it? Pi into r to r. Okay, pi r square. Okay, so this is the area of the circle. There's some other things that we'll discuss. Let's see. Okay, this is the area of the circle. Next, what we can have is a sector. Okay, first of all, we'll take the sector. Okay, I will take that. Okay, suppose this is a circle. This is the center. This line. Okay. Just consider it as a complete touching the circle. Okay. So now there are two areas. Consider this as 1 and consider this as 2. This is one part and this is 2. Okay. So this is now known as, this portion is known as minor sector. Minor sector. Okay. And what is this? This portion is called as major sector. Getting it? And suppose now there is a new thing. Just wait and I'll erase this. This is 2. Okay. Now suppose this theta, ये जो theta है, okay. This theta is suppose maybe this is कुछ भी है ये theta degree. Okay. कितना है ये angle? Theta degree. Getting it? So now if you want to find out the area of the minor sector maybe, or the area of the major sector, then how will you do that? Do you have any idea? Do you know the full angle inside? Full round angle?
360.
360. Okay. So we'll use that. So for 360 degree angle which is full, ये पूरा ऐसा 360 हो जाएगा 60 डिग्री। ओके, ऐसे पूरा 360 हो जाता है ये, यू ऑल नो इट। 360 डिग्री में द एरिया ऑफ द सर्कल कितना है पूरा, पाई आर स्क्वायर। ओके, सो इफ वी टेक फॉर 1 डिग्री, 1 डिग्री का कितना हो जाएगा एरिया, पाई आर स्क्वायर डिवाइडेड बाय 360। ओके, नाउ वी टेक फॉर थीटा डिग्री। ठीक है, सिंपल कैलकुलेशंस आई एम डूइंग। कितना हो जाएगा ये, पाई आर स्क्वायर डिवाइड बाय 360 इंटू थीटा, ये आ गया। ओके, so this is the area of the minor sector, or for that matter any sector which is having an angle theta, but in our case we are taking it as minor sector. Okay, theta angle, theta degrees. So this is simply a formula, you can just know it. Okay, so we can say that area of minor जो भी हमने शो किया, ओके, सेक्टर कितना है, this is this, getting it? Simple thing we have shown, like 360 degrees when
Yes,
it
sir.
is, what is the area, pi r square. Okay, 1 degree we are taking pi r square by 360, anyone can understand that. And theta degrees, okay, you have to multiply by theta, pi r square by 360 into theta. Okay, so this way you can calculate the for major sectors also. Okay, suppose the angle is 30. Okay, theta is equal to 30 degrees suppose. Okay, so what will be the area of minor sector or sector, है ना, सेक्टर और सेक्टर कर भी लिख सकते हैं। कितना हो जाएगा, 30 डिवाइड बाय 360 इंटू पाई आर स्क्वायर। ओके, ये 0 0 कट गया, 2 ओके, सो इट इज इक्वल टू पाई आर स्क्वायर डिवाइडेड बाय 12। pi r square divided by 12 in this case. Okay, so we have just taken an example. Okay, so this was area. If I suppose ask you what is the length of the arc, okay, in the same thing, if I ask you this length, let me draw it green color, itni. Okay, what is the length of this arc? Arc कर सकेंगे पता? Do you have any idea? For minor sector there is an arc also. Okay, कितनी है ये, सपोज ए और यहाँ तक बी है, ऐसे मान लो ए बी। Okay, the length of the arc AB, ये जो arc है. Okay, so if I want to know that for this angle theta for this minor sector, okay, and how can I do that? ठीक है, area we have covered. Now see the, it's a way like a kind of a parameter. Okay, parameter for that particular sector, whichever you are, it is minor, major, doesn't matter. Okay, you know the theta could be like more than 100 also, it could be less than 50 also, whatever. Okay, so length of the arc for minor sector, हमारे केस में कितनी है, ए बी है फॉर एग्जांपल. ओके, we can find that out. So the same thing goes over here also. Okay, for 360 degrees, what is the full arc, which is the parameter? Okay, 2 pi r पूरे सर्कल के लिए. For 1 degree it will come out to be 2 pi r divided by 360. Okay, so now for theta degree it will come out to be, कितना हो जाएगा? Okay, 2 pi r और into theta divided by 360, ऐसे भी लिख सकते हैं उसको. ठीक है, getting it? लेंथ ऑफ द आर्क ए भी इस तरह से आप निकाल सकते हो. ठीक है, whatever the angle is given, you same thing applies over here also, so you can maybe directly, but you should know the proof also. It's a very simple proof. Getting it? Now we'll take some segments. Okay, let us take sector instead of sector. Now we'll take segment. Okay, how we can define segment? We just take the color as, okay, same thing. This is the center, suppose. If I'm taking it like, okay, the same thing. So what, let me, this will I'll draw later. Okay, you can consider this one. So this area, ये वाला जो है, okay, so this is called as minor segment. Okay, the upper one is called as major segment. So suppose if I ask you to find the area of this minor segment, how can you find that out? Can you tell me? You know the area of the sector, how to find the area of the sector? Okay, so to find out the area of this minor segment, suppose I'm using, this is O, maybe this is A, this is B, and I'm taking a point on this boundary which is called as P. Okay, don't confuse it with any other point. It is a point on the boundary, just to name that arc. Okay, so now if I want to find the area of APB, suppose that segment, okay, then how can I find? Any hints? Okay, and this is same
Sir, segment.
theta. Segment is AB, APB, that area, that arc. Okay, and below that horizontal line AB, this is minor segment, and all the area above it is called major segment, suppose. Okay, suppose this line AB, if it is passing through O, then it will be the diameter, then it will cut the circle in two halves, right? आधे आधे हो जाएंगे. Okay, both will get halved. लेकिन in this case this line is not going through the center, this is like somewhere below. So the portion of the area that is covered by that arc APB and with this line AB is called as minor segment, and all the area above is called as major segment. Getting it? So now if you want to find out the area of this minor segment, then what strategy can we apply? Plain observation. You should observe. Take a pause and think क्या हो सकता है. Suppose if I ask you to have the area of the minor sector. So what is that? O A P B O. इस तरीके से हो जाएगा. Okay. And that the formula that we already know. Minor sector का कितना होता है? Area I am asking. Okay. So this is the area. Pi r square divided by 360 into theta. Getting it? Radius is r, of course. So minor sector का area, we have got the area of the minor sector like this. Theta divided by 360 into pi r square. Getting it? And now if we somehow know the area of this triangle OAB, okay, can we get that from that sector if we subtract the area of the OAB triangle? Do you think we will be able to get that segment, minor segment? Okay, let me just do some changes. Make a space so that I can get it over here itself. माइनर सेगमेंट है ये, ठीक है. तो अभी एरिया ऑफ इसका जो एरिया है, ओके, कितना होगा थीटा theta divided by 360 into pi r square. ठीक है, getting it, minus area of triangle OAB. OAB समझ में आ रहा है? Minor segment means that whole sector OAPBO. ठीक है, area of it is theta divided by 360 into pi r square minus area of triangle OAB. Okay, in that way you'll get this area of this minor segment. Getting it? Making some sense? Getting it or not?
Yes, sir.
ठीक है ना? Theta divided by 360 into pi r square minus area of the triangle OAB. So it is a plain logic. Okay, I am getting first of all the whole area of it OAPBO, and I'm subtracting the area of the triangle OAB. I'm not going into the specification of it. OAB, how you will find? You will be able to find that. Either you break it into the two right angle triangles. Okay, you draw a perpendicular from O on AB and do that. But that will be given to you. Okay. So this way you can find the this. And similarly, if you find the area of how do you find the area of the major segment? कैसे मिलेगा? Major segment means above 1. Okay. Okay, so full area minus this minor segment. Can we get that? तो मिल जाएगा हमें फिर. ठीक है. Full area of the circle, that is pi r square minus area of this minor segment. Getting it? Which is theta by 360 into pi r square minus area of the triangle OAB. If you take this in the bracket and if you subtract it from pi r square, you will get the area of the major segment. Getting it? Okay. So just a small recap, because I'll then move to the slide. My slides are finished. Okay. So this is a sector. How you know the sector? Okay, this is minor sector. Depends upon totally upon theta. Okay. Major sector, if you want to have the area of it, simple calculations, 360 pi r square. Okay, 1 degree, so pi r square divided by 360, and theta degrees multiply by theta. Okay, this is the area of the minor sector. Similarly, we have taken, like, if it is 30, then we have shown pi r square by 12. Okay, you can also take that. Length of the arc AB, same goes for the arc 360, 2 pi r. 2 pi r is the whole parameter. 1 degree, 2 pi r divided by 360, then theta, 2 pi r divided by 360 into theta. Okay, same thing. Now you've got the segment. What is segment? Segment is that below area, below AB, line AB, that area is called the segment. Since it is the small one, we are saying it minor, and the top one we are saying it the major segment. Top one is above AB. Okay, all area. So the area of this would be, a smart move would be like to find the area of this sector, minor sector, and divide or subtract the area of the triangle OAB. That is what we are doing. Okay, so then you'll find the area of this minor segment. Major segment, how can you find? Whole area of the circle is pi r square subtracting area of the minor segment, which is given over here. So you will be able to find that also. Getting it? Okay, radius is r in this scenario. Okay, getting it? Area of triangle OAB. Okay, okay. So I'll move to new slides. Let me show you the area of the major segment also to see. Okay, just take it in this fashion. Okay, so if this is like, suppose this is our this thing. Okay, major segment. Okay, minor we have covered. Trying it again, just wait. Hmm. P. Okay, R. So previously we had taken this small point as P. Okay, A P B, and if we take this point as Q, suppose. Okay, then the area major segment कितना होगा देख लेते हैं. Area of segment कौन सा है हमारा A Q B A, फिर से ऐसे ले लो. ठीक है, so this will be pi r square, which is the total area. Okay, I have it in blue. Pi r square minus area of minor segment. Area of minor segment. Okay, which is also like pi r square minus, which we have previously found out. What was it? Theta 360 into pi r square minus area of triangle OAB. O triangle triangle OAB. Okay, we'll close it like this. Might seem a little complicated, but it is plain. Okay, full area of the circle. We are subtracting the minor segment. So this how you can apply simple tricks. Okay, simple logic, plain logic. First of all, you should understand what is that. Once you understand the definition, then these things will become simple. Okay. Okay, getting it? Now suppose, have you ever given a thought if I like if I draw any triangle inside a circle? Okay, suppose this is a nice circle. This is the center of it. Suppose I'm like shape. Okay, I'm taking this one. Okay, if I suppose taking this triangle. So what do you think? What kind of triangle it is? Is it a equilateral triangle? Could be a isosceles triangle, or could be something else. Suppose if I draw any triangle and one of the vertices of that triangle is center O, and other two vertices are always lying on the circle, then what kind of triangle would it be? This is just an observation question. One vertices would always be center and other two vertices would be lying on the circle circumference. Okay, somewhere on the circumference. So one example I am showing it to what type, which type of triangle will it be?
Sir, equilateral.
Equilateral could be equilateral, but generally it would be
Sir,
isosceles.
isosceles है.
Isosceles, okay, isosceles तो होगा ही. Okay, and it could be equilateral also in some cases. You can also like infer that. Okay, whenever this AB is equal to R, suppose, then it will be equilateral. Getting it? If OA is equal to AB is equal to, in some cases, okay, is equal to OB, तो ये क्या हो जाएगा? This will be an equilateral. Lateral triangle. Okay. Getting it?
Yes, sir.
Okay, but suppose if is not equal to AB. ठीक है, suppose OA is equal to OB, ये तो होगा ही, it will always be there because it is a bounded kind of a triangle. So you can use these things, maybe not now, you will understand. These can be some energy bounded functions. Okay, suppose this circle is a finite resource of energy, finite energy I have. Okay, so inside energy, if I am having these triangular shapes, okay, so they will always be like isosceles triangle, anywhere you can put. Okay, one vertices, take it at O and put it at any other place, so all the both the two sides would be always isosceles, always equal. Why equal? They are radius, because they are the radius. So this is kind of a bounded triangle. Okay, so there could be some nice condition. How could R vary in this? Not R, AB, the length of AB. ठीक है, इस केस में it will be an isosceles triangle. First of all, let us complete this. What is the spelling? Isos होती है, क्या होती है? You remember?
OS होती है.
ISO. हाँ
ISOSCELES.
हाँ, ISOS होती है वहाँ बीच में, करेक्ट. इसको थोड़ा कर लेते हैं, ठीक. SCELES. ओके, ऐसे हो सकते हैं. जब तीनों इक्वल होंगे तो इट विल बी इक्विलेटरल ट्रायंगल. ये होगा तो ऑलवेज दिस इज अ काइंड ऑफ एन वेरी इंटरेस्टिंग ऑब्जर्वेशन इन सम काइंड ऑफ अ डिजाइन प्रॉब्लम. सपोज यू आर फेसिंग समथिंग. ओके, and what I was thinking when I was like thinking of this thing, so it is kind of energy bounded functions. Okay, why I'm saying bounded? Because circle is a boundary. Okay, inside this thing I have to just, for example, if you take our body, human body is also kind of a finite resource. Okay, whatever chit we have, it is inside this body only, we are given, and we are moving with this body. That is another thing, that it has quantum properties, but body wise you are like, you have a finite resource. Okay, so it is chit is inside always this body, and you have to like carry it, and you have to do several activities with it. Okay, so this is also kind of a finite energy system. And inside that, wherever like you make a triangle where one vertex is at 0, other two vertices कुछ भी ले सकते हो आप, तो वो it will be an isosceles triangle. And there could be some nice thing around. Let us see. Just give me it. I'm trying to show it over here. Suppose I'm having this triangle. Okay, okay, like ये triangle है, suppose, है ना? Suppose there is one more triangle like this. See it. very small, like this. Okay, so if you see these a, this is AB, and let me take this as A dash. This will be useful to you in something. No. And this is suppose A double dash, and this is B double dash. Okay, so I'm taking different scenario of the same triangle. So now if I see the length of AB, maybe I'll take the length of AB. So condition for length of AB. So can I write AB, since it is a bounded function? AB will be always smaller than 2r. Can I write this? Not equal to, and will be greater than 0. Can I write this for AB? Tell me. देखो ए बी अगर बहुत, इफ इट वुड बी वेरी स्मॉल लाइक इन द टॉप ए डबल डैश बी डबल डैश ट्राइंगल, ओके, बहुत छोटा हो जाएगा जब वहां पर, सो इट विल बी ग्रेटर देन जीरो, बट इट विल नेवर बी जीरो, क्योंकि अगर जीरो हुआ तो इट विल बी वन लाइन ओनली. ओके, so this will be the condition, boundary conditions. AB can be should be greater than 0 and should be smaller than 2r. Why smaller than 2r? Take the example of a dash b dash. Okay, in this case if I like take it little on the bottom side, ऐसे करके लेता हूँ मैं इसे दोनों चीजों को, तो ये it will become diameter only, it will become one line. Okay, but that won't be a triangle, so the condition would be it will be smaller than 2r always. Okay, so this is kind of a bounded condition, bounded condition. Okay, just wait. Smaller than 2r, greater than 0. Okay, ये bounded condition है इसकी. Because I sometimes do this work also for regarding the energy things. Okay, so this is kind of a, so human body is also kind of this thing. That is why they say human body is kind of a mini cosmos. Okay, that is the fact. Human body is a mini cosmos, and inside that you have like all the resources, okay, to connect to every locus, everything. But only thing is you need to walk the path slowly. Okay, and you cannot misuse it, should be for the benefit of the mankind. Okay, so these things, this is how math is related to the real systems. Okay, you can have this like applications of this thing into the energy bounded systems also, the human systems also, um, wherever. Okay, you can have your use cases as per the requirement. So this was some extra information, and we'll take some things in the next lecture. Okay, so I'll finish this lecture on this note. Okay, to see you in the next lecture. Take care.
Thank you, sir.
Yeah, take care. Bye.
Thank you, sir.
Thank you.